Bismillahirrahmanirrahim. In this lecture, I am solving problem 6.60 from Fundamental of Thermodynamics by BORGNAKKE. So the statement of the problem is saturated liquid nitrogen at 600 kilopascal. So it means that initially nitrogen is saturated liquid. It means that initial point will be on the saturated liquid line and initial pressure is equal to 600 kilopascal. Enters a boiler at a rate of 0.005 kilogram per second. It means that mass flow rate is equal to 0.005 kilogram per second and exits at a saturated vapor. See figure 6.60. This is figure 6.60. It then flows into a superheater also at 600 kilopascal where it exits at 600 kilo. There are three stages. This is stage number 1, this is stage number 2, and this is stage number 3. Stage number 1 is entrance of the boiler. Here pressure P1 is equal to 600 kilopascal. Stage number 2 is exit of boiler and entrance of superheater. Here pressure is equal to 600 kilopascal. And stage 3 is the exit of superheater. So here also pressure is 600 kilopascal. It means that pressure is constant in all states. Where it exit is 602 and here temperature T3 is equal to 280 Kelvin. Find the rate of heat transfer in the boiler and the superheater. Find rate of heat transfer in the boiler and rate of heat transfer in the superheater. So for this we will find H1, H2 and H3. Here it is clear from the statement that at the first stage here nitrogen is saturated liquid. This is clear from the statement. Saturated liquid nitrogen. Then an exit saturated vapor. Exit a boiler. This is saturated vapor. And this is the exit of superheater. And after superheated, this is superheated vapor. So we can easily draw it on PV diagram, also on TS diagram. This is the PV diagram, pressure in kilopascal and volume in meter cube per kg. So the saturation curve is such like this. Constant pressure line. Initially this is state 1. Here it is. This is state 1. And here pressure is, this is state 2, saturated vapor, and this is superheated vapor. This is state 3. This is 1, this is 2, and this is 3. So at this point H1 is equal to HF, and this point H2 is equal to Hg, and here superheating state H3 is equal to superheating temperature. We will find this with the help of superheated table. Similarly, we can draw it on TV diagram, temperature in degree centigrade and volume in meter cube per kg. Yeah, temperature in Kelvin. Here temperature is in Kelvin. So this is the saturation curve, and constant pressure line on TV diagram is such like this. So this is H1 is equal to HF. This point 2, this is point 1, this is point 2, this is 0.3. This is H2 is equal to Hg, and this 0.3 is H3. So first we find H1, H2 and H3. So H1 is equal to Hf. So we will find this from saturated table of nitrogen. So for H1 from saturated table of nitrogen, pressure P1 is 600 kilopascal. At 600 kilopascal, find H1 is equal to Hf. So pressure in kilopascal and Hf. Similarly, we can find directly H2 because H2 is also H2 is equal to Hg, and it is also at 600 kilopascal. So find H1 is equal to Hf and H2 is equal to Hg. H1 is equal to Hf and H2 is equal to Hg, and in both cases pressure is 600 kilopascal. So H1 in kilojoule per kilogram and H2 in kilojoule per kilogram. So if we check 600 in this table, it is not available in the table. This is pressure column. This is per nitrogen. This table is per nitrogen from the book. So here 600 kilopascal is not available, but 541.1 and 779.2 are available. So we will interpolate between these two values. 541.1 is available, 541.1 kilopascal, and 779.2, and we have to find H1 and H2 at 600 kilopascal. So in front of 541.1, HF is equal to, this is HF, minus 73.20, sorry, minus 84.59, minus 84.59, and in front of 779.2, this is minus 73.20, minus 73.20, and we have to find H1 at 600. Similarly, H2 is equal to Hg. In front of 541.1, Hg is equal to 171.01, 171.01. This is HFG. This is not Hg. This is HFG. Hg is 86.47 and 87.48. 86.47 and 87.48, and we have to find H2. So first, by interpolation, we are finding H1. So H1 is equal to, sorry, by interpolation, third value minus first value, third value minus first value divided by third value minus second value is equal to third value minus 73.20 minus first value divided by third value minus second value. So find H1 from this. So H1 is equal to minus 81.77 kilojoule per kg. Now per H2 by interpolation. By interpolation, so do interpolation in pressure value, and in H2 values. So 779.2 minus third value minus first value divided by third value minus second value is equal to third value 87.48 minus 86.47. 87.48 minus 86.47 divided by third value minus second value, which is H2. So find H2 from this. So H2 is equal to 86.7198 kilojoule per kg. Now for H3, use superheated steam table. This is after superheater. H3 found is, this found is after superheater. Found 3 after superheater. So we will use superheated table of nitrogen. Now from superheated table of nitrogen at pressure P3 is equal to 800 kilopascal and temperature T3 is equal to 280 Kelvin. Find H3. So this is the superheated table of nitrogen, and this pressure is 600 kilopascal. This pressure is, and this is the temperature of 280 Kelvin. This is the temperature of 280 Kelvin. So in front of 280 Kelvin and 600 kilopascal, find H3. This last value is of H3. This is value of H3, 289.05. 289.05 kilojoule per kg. Now we can find rate of heat transfer for boiler and condenser. So rate of heat transfer for boiler is m dot h2 minus h1. m dot h2 minus h1. This is boiler, this is h2, and this is h1. So m dot h, here this is h1, this is h2, and this is h3. So m dot h2. There are also some other values which we neglected. The equation is basically already explained in the previous problem. Q dot minus W dot plus m dot h1 plus v inlet square divided by 2 plus gz1 is equal to m dot h2 plus v exit square plus gz2. In boiler, W we neglect work. Similarly, velocity is uniform and potential energy also negligible. Change in potential energy is negligible. So it means that the final equation is between Q, H1 and H2, which is this. So Q dot boiler, putting values, is equal to m dot is 0.005 kilogram per second, and H2 is equal to 86.7198 minus 81.77 kilojoule per kg. There are two minus, so it will be plus. So add these two values and multiply by 0.005. So Q of boiler is equal to 0.842, and this kilogram will be cancelled with kilogram. Kilo and joule per second is equal to watt. So this is rate of heat in boiler is 0.842 kilowatt. Now rate of heat transfer in superheater, which is equal to m dot h3 minus h2. Just like above equation is this, but other terms are neglected. So Q dot is equal to m dot h3 minus h1. So Q dot in superheater is equal to m dot is 0.005 kilogram per second. H3 is equal to 289.05 minus H1 is H2 is 86.7198. 86.7198 kilojoule per kilogram. Kilogram is cancelled with kilogram. So rate of heat transfer in superheater is 1.01 kilowatt. 1.01 kilo and joule per second. Joule per second is equal to watt. So this is the end of the problem, and for more problems please like and subscribe my YouTube channel and share with your friends. Thank you.